Okay, so in this particular video, we are going to see about the buffer overflow attacks. So far, we have gone through the basic understanding of memory corruption attack. Now it's time for us to deep dive into the buffer overflow, try to understand the buffer overflow attack. How does it actually happen? And then what the next thing that we are going to do is we'll try to execute this buffer overflow attack in a very controlled environment. Obviously, we're not going to harm anything in the real world application. So we have created a very controlled system. So basically there are a lot of boxes that are available online, and we'll be using one of those boxes, and we'll try to attack those boxes and try to learn the what are the concepts that we are going to understand in this particular video, and we'll try to implement these concepts throughout the next couple of videos. The next very important thing that you have to understand about the buffer overflow attacks, or any overflow attacks that you do, is you have to practice a lot. It's easy to understand the concept, and then while you are in a swing of of the videos, you try to get hold of things look very easy. But when you are into a situation where you don't have a solution, you have to attack it by yourself, you kind of get messed up over there. So my advice for everyone is to practice as much as possible. Anyway, so let's try to understand the buffer overflow attack. Okay, so what is wrong with the buffer? In the previous video we have seen how the program works, right? So in this particular video, we are going to understand and take those stack heap, whatever we have understood in the previous video, we'll take those things to the next level, where we are going to understand about the buffer overflow exploitation over here. So in this particular, what I have done is like this is the low memory address, this is the high memory address. We have the buffer overflow, we have the the base pointer, which is ABP, and then finally we have the return address. And the whole idea is that we kind of like fill these buffer with whatever some random numbers. Okay, so that's basically what the buffer is. It kinds of hold whatever the value that it intends to be. So maybe the buffer has, let's say, 100, so it can hold up to 100 characters over there, right? But what happens if if you increase from 100, instead of 100 you add 101, it kind of override these things, and it just starts overriding the EBP. Okay, and then if you keep on doing it, you can even override up to the return address. And overriding a return address is not something very cool. It's very dangerous. If you are a programmer, in your programming perspective, it's very dangerous to override the return address, because this is the return address which points what happens after the program ends, right? So now if you think in a attacker's perspective, this is exactly what you really want to do. You really want to take control of the return address. Okay, point out to something which you want. Okay, now let me just show you what is wrong with the buffer. To be honest, everything is wrong with the buffer. So in this particular image, what I have done is like this entire thing is filled with our malicious code. What is there exactly is that uh, let's say again, there's a buffer or size is 100. Okay, you fill that with some a's, which is like, okay, so let me just multiply by 100, which means 100 a's. Okay, you fill the entire thing with a, and so on and so forth. Okay, and obviously inside, okay, I'm not sure because the color is not very much clear. Anyway, then you again add 4 b's, okay, which will again be filled into the base pointer. And then again you add c, which is 4 times again, because again the return, this return address will be filled with c. Okay, so this is how you entered all these values in the buffer, the base pointer, and the return address. So once so what exactly happens is once the program ends, it will try to find out where the return address is. So it will see, okay, the return address points us to CCC, right? And then it will try to go to that particular address wherever this address stays here in the entire program. Now, this looks cool. Okay, you know where what you can do with the buffer. You can store some stuff in the buffer. You have EVP. You can override the return address. Now, what exactly with all these combinations? Okay, what exactly that you can do? Right, that's the next thing. So the next thing is to actually create a exploit which can perform whatever you want, or so I'll just explain you in the next slide. Let's go actually to the next slide, in fact. Okay. So this is the initial buffer, right? And in the, once you have all this, the malicious code, you all these buffer, base pointer, return address, they are override written. So what you can do is, so there is something called shellcode. So basically, shellcode are bunch of hexadecimal characters, which are created in order to do some certain specific tasks. So for example, if you want to run some sudo command, let's say sudo su. Okay, so there is a shellcode which looks like x. Okay, let me just x, a b, or I don't know, bunch of characters, maybe 40, 45, I don't know. So it really depends upon the length of the shell code. And these shell code, what when you execute this shell code, all these commands are basically getting executed. Okay, so that's exactly what is called shell code. So executing these shell codes are very dangerous. So for example, if you store those shell code, and still the idea is to store this shell code in the buffer. So for example, if you store, let's say, these I don't know, I'm not writing any shell code over here. I'm just writing some random numbers over here. So let's say this is the shell code. Okay, so what you do is you put the shell code in the buffer. Okay, and then you try to find out the address of this particular shell code from where it starts. So let's say this starts from A B C D. Okay, this is the address of the shellcode from where the shellcode starts. Okay, now in the return address, what you do is you point out this particular address of the shellcode over here, right? And so what happens is once the program ends, it tries to find out the return address. Okay, it says, okay, it sees that, okay, the return address is abcd. Then it will actually go to this abcd, and then it finds out, okay, in abcd there is a particular command that I'm supposed to execute, and this particular command is a shell code, but the program does not know because it just obeys and whatever it sees right in front of it, right? So it sees that, okay, there is a command, and it then execute the shell code. And then so if the shell code is like giving you a root access, you can actually go and take that particular access, right? So yeah, more or less that is what the shell code is all about. But the next problem over here is to find out this particular address. Okay, even if you find out the address, the next time you execute the address of the shell code actually gets changed. Okay, there are a lot of techniques that is being implemented inside the memory, which randomizes where you store the information in the buffer. Okay, so that's the next challenge. So for example, if you find out that abcd is the challenge, abcd is the address, the next time you try to execute this abcd, so maybe that return address, the address of the shellcode has already been changed. So that might not even point to the shellcode, and it might point somewhere in the middle of the shellcode or before the shellcode, so you don't really know. So what you can do with that? Okay, so the whole idea is to point to to cope up with this is to use knobs. So knobs basically means x90. Okay, so knobs basically, is something which says go to the next. So once the program sees that it's knobs, okay, it says okay, I'll go to the next memory address. Okay, so basically you're kind of creating a sled, right? Shellcode. So what happens exactly is that once you one and then we pass this to the return address, right? So what exactly happens is once you try to execute this, okay, obviously the address might have changed in the next execution phase, but still there's not a lot of randomization. It randomizes like 2 3 up 2 3 down, which you are not sure of. So but still, if you're pointing it at the middle of the knob sled, even 2 3 up or 2 3 down, it's still a knob sled, right? So this knobs takes you to next, and finally doing all these next, it finally comes to the shellcode, and then it finally says, okay, I got something which I understand, and this is something which is not knobs. This is something which is actually part of the program, and it is a exploit, right? It's a shellcode, and then it executes the shellcode. So that's the whole idea is all about. Now this whole concept looks very much simple because it's just simple that you have a buffer, you try to find out the length of the buffer, then based upon the length of buffer you do some, you hit some knobs, and then hit some shell codes to override the buffer, and then you finally kind of find out that particular address of the buffer where the knob sled is, and then you put those things in the return address and you override, and you then execute it, right? And once the program execute, what you do is like it goes to the knobs. Through the knobs, it goes to shellcode, and then that particular shellcode executes and it gives you the root access over that, the access that is being provided by the program. Okay, so that is more or less how the buffer overflow attack looks like. So in the next video we are going to see, we are going to actually run this buffer overflow attack in some controlled environment. Till then, goodbye.